Welcome to the Biomedical Engineering Project construction of a low-cost mechanical hand. The group members are Amir Bayter, Jason Corredor, Gabriela Davila, and Carlos Guerrero. Nowadays, there are many research in this field, as well as companies, like Open Bionics, Sarco Research Corp, Altec Inc., KCF Technologies. Also, there is plenty of designs like the one made by the company Tasca. Tasca products can cost between $35,000 and $11,000. This is a high cost that many people cannot afford.
Prosthetics is one of the biggest branches of biomechanical engineering today. It is very common that we can find prosthetic hands, fingers, forearms, legs, or even arms. But also, it is very common that these parts, even if they are small, tend to be really expensive, and not always tend to imitate some other natural movements of the human body. This is one of the main reasons that we wanted to create this project. A prosthetic hand that can be, with time, into a forearm that tends to be cheap, but also tend to replicate some of the natural movements of the body, such as reflexes, which is one of the next step that we, as a group, want to achieve by measuring the natural movements of a real hand, and then try to compilate this data in the future to make some machine learning with some predictive models to make this hand work better.
Project details. In order to make this idea become true, we have followed some steps. First, the designing process of the hand as a 3D model, followed by the fabrication process by 3D printing the parts. Also, we determine the electronic components and drawing the circuit needed, followed by the programming of the hand to end up with our final result.
The design of this project was initially based off of the past projects that one of the group members had, but with time we decided to redesign completely this hand on SolidWorks. Basically, because we wanted to be cheaper, since the model that we're using with strings uses less motors, and also be easier because the construction is way easier. So if in the future we want to build this in mass, it will be better for any fabrics. For the construction of this project for the hand, we basically took every single part that we designed on SolidWorks and then 3D printed. Then we attached the motors and also attached the hand to a wood plate, so we could basically try to look how the hand moves based on the movements that we check and we measure with the gauntlet. So then we took just the motors, we attached them, we took the distances and then measured the angles just for the motors that we could then use a function on Arduino with fmap to then make the measurements and make the hand move with the gauntlet that we then attached. Motors, we attached them, we took the distances and then measured the angles just for the motors that we could then use a function on Arduino with fmap to then make the measurements and make the hand move with the gauntlet that we then attached.
Continuing with our electronic design, we're gonna find that the overall circuitry has pretty common components and is very easy to understand. For each of our fingers, we have a 3 set component groups: a pressure bend sensor, a resistor, and a servo motor. This is for all except for the thumb, which uses 2 servos to account for rotation and bend of the finger. For better understanding of the system, we color-coded it for each finger in the following way. Blue is for the thumb, orange is for the index, green is for the middle, purple is for the ring finger, and brown is for the little finger. The whole system has a power source of two 3.7 volts ion lithium battery, along with 5 volts from the USB port connected to the PC. Like said before, the measurement system uses a pressure bend sensor. In the right image, it can be found a simplified but accurate schematic of the system, where RB1 will be the sensor, R1 the resistor connected, and BO will be the output voltage that is received by the Arduino. RB1, our sensor, acts as a variable resistor that increases as we bend the sensor, applying pressure in it. And as the resistance increases, the output voltage decreases and is used by our code and the Arduino to give an approximate quantitative measurement of each finger's movement. Superficially but rapidly explained, the programming code used consisted initially in the positioning of each servo motor, where each string connected will be slightly tensioned and waiting for direction for its movement. Afterwards is the regulation of the voltage for each sensor, and thanks to its previously measurement in open and closed positioning voltage and servo motor angle on those positions, it was possible to use a mapping function for the Arduino to control the servo motor's angle with fair accuracy according to the signal provided. For the thumb, the signal was used for the detection and bend was the same, but with a slight temporal delay to avoid any physical obstruction on the hand.
The equipment used for the construction of the prosthetic hand was a 3D printer along with the PLA, that is the material for the 3D printing, an Arduino Uno, servo motors, wood for the base of the hand, flex pressure sensors, resistors, jumpers, breadboards, and batteries.
Across the country. Here we go back. This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Here we go back. This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Nah, can I kick it? Thank you, yeah, I'm so damn grateful. I grew up really wanna go fronts, but that's what you get when Wu-Tang raised you. Y'all can't stop me, go hard like I got an 808 in my heartbeat. And I'm eating at the beat like it gave a little speed to a great white shark on shark week. Raw, time to go off, gone, deuces goodbye. I got a world to see, and my girl, she wanna see Rome. Caesar make you a believer, nah, I never ever did it for a throne. That validation comes from giving it back to the people. Now, sing this song and it goes like, raise those hands, this is our party. We came here to live life like nobody was watching. I got my city right behind me. If I fall, they got me. Learn from that failure, gain humility, and then we keep marching. And we go back. This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Go back. This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. So we put our hands up.
As conclusions, we have that a low-cost prosthetic hand can be made by 3D printing on PLA material. Also, that make a prototype of a prosthetic hand it's harder than it looks. So the simpler the functioning system, the better. For example, it is better to use threads to move the fingers than putting directly the servo motors in each finger. And the actual thing that makes prosthetic hands a high-cost product is the electronic part of it. And programming is a very important skill that is essential to build any biomechanic artifact.
When we finished this project, we realized that there are some improvements that we should take in account for future prototypes, like the redesign of the attachments of the fingers so they move easily to the original position, maybe using some other rubber bands, or changing the attachment on the fingers so they will work better. Also use holes for the servo motors so they reduce the space of the set. They only have to make a complete rotation and just move the finger to the point where they are grabbing something. Also, the implement of a wireless measure system to ease the measurements of the hand. So we don't have that much cables and everything around just one space and being less messy. And also the implementation of a simple predictive model using PID controllers technology to investigate and emulate the reflexes on a hand. This being like the most important improvement and the future main objective that we would like to implement in this kind of projects, trying to make prostheses that are more natural and also, as we say, less expensive.